All right. Hello, everyone. Today is a little review worksheet that I gave on Wednesday. Um, Basically, it just has some proving or verifying trig identities on it. But tomorrow or Thursday, I guess tomorrow you'll be looking at this. So you also have your quiz attached to this one. I'll show you that momentarily. But I want to give you the answers to these review questions so you can use these on your quiz. Your quiz again is due Sunday night by 11:59. It's 9 questions. It has 4 simplifying and 5 verifying, and a bonus. So you could get over 100%. It's like 20, 9 question, 3 points each is worth 27 points, but you could actually get 30. So, um, so yeah, make sure you do that. But here I'm going to go over some answers. I don't think I'm going to get all the answers to fit on this one page. So I have some extra pages to add the answers in here. So all right, so let's take a look at these. Again, it just basically says prove, or which is the same as verifying, to show the left side is equal to the right side. So again, you can work on whatever side you want. Okay, you can work on whatever side you want, but you got to make again both sides equal. So if I look at number one, I'll bring number one over here. Number one, I have sine theta equals cosine theta tan theta. So which side looks more difficult? Well, there's only one thing on the left. There's 2 things on the right. So I'm going to go ahead and leave. Okay, left side the same. Cosine theta, I'm going to write that as cosine theta over 1 times tangent of theta is just sine theta over cosine theta. Doesn't get much simpler than this. What happens? Our cosines cancel out, and we get sine theta. Check. That was easy. Well, number two. So number two, when I look at number two, probably the right-hand side again looks a little bit more complicated here just because I have 2 trig functions, where on the left I just have 1. So for this one, I'm going to leave the left side as 1 over cosine theta. I'm going to drop the theta off right now for a moment. Tangent we can write as sine over cosine, and all that is all over sine over 1. Okay. So I'm just going to go to the left for space reasons. So we got 1 over cosine equals, well, we got a fraction inside of the fraction, complex fraction. So we can do our keep, change, flip. So I'm going to keep sine over cosine as is, change division to multiplication, and flip second fraction. You notice the signs cancel out. And what are we left with? We are left with 1 over cosine theta. Number 3. So I know I'm going to be running out of room, so I'm going down here. All right, so for number 3 right here, all right, we got sine squared minus cosine squared equals 1 minus 2 cosine squared. So this is one, again, where I looked at, we did one similar to this before, where on the left side, remember, the left side does not equal 1. I know you want to say it equals 1, but it doesn't, because in order to equal 1, it's got to be a plus sign right there. And we don't have that plus sign right there. It's a minus sign. Okay? So if I look at the left side, I have a sine squared and a cosine squared, where on the right side, I just have a cosine squared. So that would tell me, you know what, I think I want to work on the left-hand side, and I want to turn that sine squared into cosine squared. Don't we know that sine squared can turn into 1 minus cosine squared? This. I still have the minus cosine squared, and that's supposed to equal what we have on the right side. Well, if I look on the left side, can't I combine these 2 negative cosine squares to give me 1 minus 2 cosine squared of theta equals 1 minus 2 cosine squared of theta. 2 steps. 2 steps. Number 2 was 3 steps. Number 1 was 2 steps. So, like I said, about that average, around that here. All right, so let's do number 4. Go back to right here for number 4. 1. Let's see. All right, so for number 4, okay, here we go, sorry. I got tan squared theta plus 1 equals 1 over cosine squared. So again, our goal is to turn one side into the other. Again, the choice is yours. Either side, really, again, and this is okay. I'm going to take a look at the left-hand side because I know that tangent squared plus theta is secant squared. Now, if I want that to equal 1 over cosine squared, then I know that secant squared turns into 1 minus cosine squared. Yeah, 1 over cosine squared theta equals 1 over cosine squared theta. So check. Okay. All right. Moving on to number 5. It's 14. I'll do a couple more. I'll stop this video and then pick up another one. But let's do number 5. Let's do number 5 back in blue. I'm going to squeeze number 5 down here. So if I look at number 5, 1 minus cosine squared equals sine times cosine times tangent. To me, the right-hand side has a lot more going on. Okay. So if you want to work with that side, you can. Again, you could also work with the left-hand side because doesn't that just equal sine squared? You have either choice. Again, a lot of these here are either way that you can do these problems. So for number 5, oh yeah, I was going to do 1 minus, leave the left side alone. It really is either way. Equals, let's say, sine over 1 times cosine times sine over cosine. Don't our cosines cancel out to give us 1 minus cosine squared equals, looks like I just have sine squared on this side. And what do we know about sine squared? It equals 1 minus 2 cosine squared. Ooh, I forgot my thetas this time. Check. Okay. Okay. All right, I'm going to do one more in this video here. Number 6. Number 6, again, I hope you agree that the left side definitely looks a little bit more. Got multiplication on the left. You don't have anything on the right except for the sine squared. This one's easy. This one's easy. So for number 6, I have cosine squared over 1 times, I got tan squared, so isn't tan squared sine squared over cosine squared? That should equal sine squared. Right, equal sine squared. What happens here? Cosines cancel out, and we get sine squared of theta equals sine squared of theta. Check. Right, well, that's my dog. I apologize. I had to pause this video for a second while she comes down. Actually, I'm just going to stop this video, and then I'll pick up with the remaining questions after this. Right. Thanks, guys.